So now we're going to use polynomial identities to factor and simplify, depending on if it's just variables or numbers. Essentially, it's the opposite of what we just did in example 2. So this one is 9m to the 25n to the 6th. They might not look like squares, but the coefficients are squares, 9 to 25, right? And exponents of 4 and 6 are not squares, right? But they're even, so you can take a square root of them, so then this identity applies. So essentially, we're going to use the difference of squares identity, where the square root of 9m to the 4th and 25n to the 6th are a and b. So then once you simplify it out, you end up with 3m squared minus 5n cubed squared. And then from there, you work out what those are, and then you're basically backing out into the factors. So you're factoring it. This one is x cubed minus 216. This would be the difference of cubes identity. So in the identity, a is the cube root, in this case of x cubed, so a will be x. And then the cube root of 216 will be b, so b will be 6. So you end up with x minus 6 times x squared plus 6x plus 36. And those would be the factors of x cubed minus 216. You can also do this with just numbers. So this is the part where we're talking about simplifying. So in this case, 11 cubed plus 5 cubed. Well, in the formula, the cube root of 11 cubed is a, so in this case it's 11. And the cube root of 5 cubed is b, so b is 5. And then we substitute those into the identity, simplify, and you get 1,456. So on the try it page, we've got basically one of each of those three. So give them each a try, and then pause it, try it, come back. First one, m to the 8th minus 9n to the 10th. That is a difference of squares. The squares are m to the 4th squared minus 3m to the 5th squared. So it ends up being m to the 4th plus 3n to the 5th times m to the 4th minus 3n to the 5th. Part B is a difference of cubes. The cubes are 3x cubed minus 7y squared cubed. So when you substitute that into the formula, remember it's a minus b, so a is 3x cubed, b is 7y squared, times a squared. So you got to do 3x cubed squared. Parentheses important here because you need to square the 3. Biggest mistake I see applying this identity is squaring the variable and the exponent on the variable, but not squaring the coefficient. So leaving this as a 3 instead of making it 9 would be the biggest mistake I see applying this principle or property. Then it's a times b. So again, a is 3x cubed, b is 7y squared. So you multiply them together for that middle term. And then b squared. b was 7y squared. So you just square that. And again, squaring the coefficient and the variable with the exponent. So what you end up with is 3x cubed minus 7y squared times 9x to the 6th plus 21x cubed y squared plus 49y to the 4th. Right? And then the last part is 12 cubed plus 2 cubed. That is a sum of 2 cubes. So the cubes are, well, 12 cubed and 2 cubed. So a is 12, b is 2. This identity is a plus b times a squared minus ab plus b squared. So you end up with 14. 12 plus 2 is 14. 12 squared is 144. 12 times 2 is 24. 2 squared is 4. Simplify it up and you have 1,736. All right, let's try example 4 now.